Okay, so now let's look at the question itself. The part B, it says logic circuit need to be designed, right? So it is supposed to detect a sequence of at least 3 ones in a row. Okay, it's received via serial input. If the circuit detects 3 ones in a row, we should output 1, otherwise the output will be 0. Okay, so it's asking us to actually in the B part 1, it is asking us to draw a state transition diagram to show the complete logic. Okay, so there are some details given which can be helpful to you, so you can read it and figure out what actually it tries to say. So the circuit has 4 states S0, S1, S2, S3. Okay, and one input signal. So states also like named what is the purpose of each state here. But if you are not familiar with what we are trying to do, right now we have an input and we have a set of states, right? So now this one is asking for us to have to detect uh, 3 ones in a row, right? So in order to get that, we need to have how many states now. So we can determine that. For example, if you have a no, I mean, if, let's assume there is an input and it just gives us zeros all the time, right? At each time interval, it will be giving us a 0. So if it is 0 0 0 0 like that, it will be giving us inputs, right? Because it's a serial input for us. But if it is the 0, then we will be in a state where the last value in the input is also 0, right? It makes sense, right? So S naught. So S naught is there where we have a, let's say, S naught, right? S naught is where input is 0, right? So yeah, so then we have a, let's assume that there is a single one coming in our way, right? If there is a single one coming in our way, then we are going to go from, as given in this list of state descriptions, last value in the input is 1, right? If last value is in the input 1, we are going from S naught to S1, right? Does that make sense? So think for yourself. Okay, so we have an input, and if the input is 1, right, I equals so there is single input, so I can write like I equals 1, or I can just say 1 itself because I don't have to mention if it is only single variable. Anyway, so now here we have 1, right? It transitions because there is 1. Now let's say there is another 0 coming after 1, right? There's only one ones in the sequence, and again the next input will be just uh, just 0. So in that case it has to go back, right? Because we don't need to continue our state transitions because it already failed our criteria to satisfy our conditions of 3 ones in a row, right? So it will be going back actually to the this state. So it is the 0, right? But what happen if we are in the state 1 and we get another 1, right? Then we are actually going to the S2. Last two values of the input are 1. Okay, so it is S2, right? If I is 1, we will be going this way. Okay, I equals 1. Okay, so from there we can go for other state as well, which is S3, right? S3, right? We get another 1, we will be at I equals 1, then we will be at S3, right? So any of these state, if we get a 0, what will happen? We need to reset everything, right? Because we don't need to continue, we need to reset it to the current state because we got a 0, right? If I got a 0, I will be going back to I equals 0, then I will go back to S0. Okay, this is the same for other situations as well, right? Here I equals 0, correct? Where else? That's it, right? But what happened if we got all three ones now and the next one is also 1? Then here we are at S3, right? We already got three ones, but after that we get another one. What happens? So we need to stay here, right? This is the state because 4 ones also means the last three ones are 1, right? Last three inputs are 1, right? So if I equals 1 at S3, you will be staying in the same state. Okay. So now we have to analyze it a bit further to see whether we have uh, all the possible transitions, right? Because at any state we could get a 0 or 1, right? So here at S0, do we have any transition available for 0 now? No, right? So we have to have another transition here. If we are at S0, if we get I equals 0, right? Sorry, I equals 0, right? I equals 0, we will be staying at the same state. And if we equals state 1, if we get 0, we are going back. If we get 1, we are going forward, right? In S2, if we get 0, we go back to S0. If we get 1, we are going back to S3. Here also we have outward transitions for I equals 1 and I equals 0. So now as you can see, our state transition diagram is complete.